Today we're going to look at surds. So surds are numbers left in square root form, e.g. square root of 5, square root of 3. These are important when detailed accuracy is required in a calculation. We're going to be looking at surds today, and surds is actually a very easy way to pick up marks in a GCSE exam. So in today's lesson, I'm going to show you how to multiply and divide surds, how to add and subtract surds, simplify the surds, and then in some question you will see surds in a bracket. So I'm going to show you how to multiply out brackets with surds, and then I'll finish off with how to rationalize the denominator. So let's get started, guys. So some numbers cannot be written as exact decimals or fractions. Roots that cannot be written as exact decimals are called surds. So here you could see some examples. Square root of 2 is equal to 1.414, and the number keeps going. You got square root of 3, 1.732 dot dot. Square root of 5 equals 2.236, and the number keeps going. So these are all surds. Whereas on the left hand side you got square root of 4, which is equal to 2, because you could simplify square root of 4. Square root of 16, you could simplify it down to 4. Square root of 49, you could simplify it down to 7. So all of these are, if you look at them, they are square numbers. So square numbers are not surd. Any numbers that could simplify to a rational number, these are not surds. So let's look at multiplying surds. So multiplying surds are quite straightforward. So here you got an example, square root of a times square root of b. Here, when you multiply a and b together, you get ab. So the answer is square root of ab. So let's look at an example. You got square root of 5 times square root of 6. So if you multiply the inside together, 5 times 6, so that gives you square root of 30. Same with this question, square root of 3 times square root of 7, you just multiply, you get square root of 21. If you have multiplying surds with the same number inside the square root, example a and a, what you do is you multiply them together, which gives you the whole number back. So in this case, you started off with square root of a times square root of a, and you get back a. Let's look at an example. So you got square root of 5 times square root of 5. You know these multiply together to give you square root of 25. And then if you square root 25, this gives you the whole rational number back, 5. Let's have another look. Square root of 7 times square root of 7 is equal to square root of 49. And then if you square root 49, this gives you 7. You could also have numbers where you have before the square root, you have another number. So here in this case, a square root of b times c square root of d. If you multiply these together, you need to multiply the outside first, a and the c. So that gives you ac. And then you multiply the b and d, which is inside the square root, as previously what you've done earlier in these examples. So if you do square root of b times square root of d, that will give you square root of bd. So let's look at an example. Here you got 2 square root of 5 times 3 square root of 6. So what you do, you multiply the 2 and the 3 together, and that gives you 6. 2 times 3 is 6. And then 5 and 6 together. Square root of 5 times square root of 6 gives you square root of 30. Another example, 3 square root of 3 times 4 square root of 7 is equal to 3 times 4 is equal to 12, and 3 times 7 is equal to 21. So these are very straightforward carrying out the multiplication of surds. So dividing surd is as easy as multiplying surd. You just divide the numbers. So here you got square root of a divided by square root of b. And the answer will be square root of a divided by b. So let's have a look at an example. You got square root of 18 divided by square root of 6. So all you're doing is opening up the square root and then doing the division. 18 divided by 6. So 18 divided by 6 is 3. So the answer is square root of 3. Square root of 30 divided by square root of 3. Well, 30 divided by 3 is 10. So the answer is square root of 10. So sometimes they actually give you the question like this with a fraction. So again, it is very straightforward. Square root of 15 divided by square root of 3. You're just doing standard division. Square root of 15 divided by 3. 15 divided by 3 is square root of 5. And as before, you could also have questions where you have the numbers before the square root. So in this case, 8 square root of 30. Remember, these are 8 times square root of 30 divided by 2 times square root of 3. Obviously, we don't need to show the multiplication sign here. we assume there's a hidden multiplication sign. So as before, you would do the outside numbers first. 8 divided by 2, that will be just 4. And then 30 divided by square root of 3 is 30 divided by 3 is 10. So 4 square root of 10. So adding or subtracting surds can be slightly trickier than multiplying or dividing. But as long as you know the simple rules, these are very straightforward. So here you got an example at the top. You got square root of a plus square root of b. And if you look closely, the letters inside the square root are different, a and b. And if you add them together, this is not square root of a and b. This cannot be added because the numbers inside the root are different. The only time you could add or subtract a surd is when the numbers or letters inside the surds are identical. For example, this one, you got square root of a plus square root of a, so this is just 2 square root of a. This is similar to assume, the square root of a is just a, so you could assume similar to a plus a is equal to 2a, square root of a plus square root of a is equal to 2 square root of a. So the next question here, you got 4 square root of a plus 3 square root of a. So 4 plus 3 adds together to give you 7 square root of a. 2 square root of 4 plus 3 square root of 4. Again, 2 plus 3 adds together to give you 5 square root of 4. Subtracting is the exact same. So here you got 5 square root of a minus 2 square root of a. So you got 5a minus 2a, which is 3 square root of a. 4 square root of 5 minus 3 square root of 5 is just 1 square root of 5. As when you do your normal algebra, when you do 4a minus 3a, you don't write 1a. This is the same. You just leave the 1 out. So the answer is just square root of 5. So surds can be also simplified. So surds can be simplified if the number in the surd has a square number as a factor. So let's look at this question. You got square root of 75, and you know the factors of 75 are 25 and 3. And we know from the multiplying rules that square root of 25 times square root of 3 gives you square root of 75. And if you could find a factor that will simplify, for example, square root of 25, we know that would simplify down to 5. So then square root of 3 will not do that. It will stay as the square root of 3 because otherwise you will get a number with many decimals. So then what you can do is multiply these together, 5 times square root of 3 to give you 5 square root of 3. So again, simplification is quite straightforward. You just find a number in the surd that has a square number as a factor, which will simplify down, as in this case here shown. So now let's look at how to multiply out brackets. So again, you should be familiar with multiplying brackets when there's just 2 plus x or something, or 3 plus square root of 5. In this case, in the brackets, we got surds, square root of 5 and square root of 5. So how to do this? We first multiply this number with this number. So 2 times 3, that will give us 6. Then 2 square root of 5, that will give us plus 2 square root of 5. And then if you look at the bottom ones, let's just do it with a different color. Square root of 5 times 3. So that will give us plus 3 square root of 5. And then if you multiply square root of 5 with square root of 5, remember square root of 5 times square root of 5 will give us square root of 25. And that will just simplify down to 5. So that means square root of 5 times square root of 5 will be just plus 5. If we then add all these together, you got the 6 and the 5 term together. So that will give us 11. And then if we just add the other numbers together, 2 square root of 5 and 2 square plus 3 square root of 5. So 2 square root of 5 plus 3 square root of 5 will give us 5 square root of 5. And that's the answer. 11 plus 5 square root of 5. Let's have a look at the question below. Again, as before, we could multiply this with this, and this with this, and then this with this, and this with this. And so if we just do the first line, 3 times square root of 7, so that 3 times 2 will give us 6. 3 times minus square root of 7 now will give us minus 3 square root of 7. So that will be this one. And then if you look at the bottom one, square root of 7 times 2, that will give us plus 2 square root of 7. And then if we do square root of 7 minus square root of 7, square root of 7 times minus square root of 7, that will give us minus square root of 49, which is equal to minus 7. So that will be just minus 7, because remember 7 times 7 is 49. So now if we get the like terms together, we got this one and this one. So 6 minus 7, that will give us minus 1. And then minus 3 plus 2 square root of 7. So remember, minus 3 plus 2 will give us minus 1 square root of 7. You don't need to write down the 1. So the answer then just becomes minus 1 minus square root of 7. Yeah, because remember, if it was just 1a, you wouldn't write 1a. You just take that 1a, you assume there's a 1 front of it. So here, very similar, minus 1 square root of 7 is just minus square root of 7. And that is the answer. Another common question in Surd is rationalizing the denominator. So here you could see the denominator is square root of 3. And what they want you to do is rationalize that number to make it just 3 on its own. And how to do this is basically what you do is you take the number and multiply it the bottom by the same exact surd. So here you got square root of 3 times square root of 3. You know square root of 3 and square root of 3 is going to give you square root of 9, and that becomes a rationalized number 3. But whatever you do to the bottom, in this case, you have to do the same to the top. So square root of 3 and square root of 3, you multiply the same at the bottom and the top. And when you did that, so then the top becomes 6 square root of 3. 6 times square root of 3 becomes 6 square root of 3. And so the top is 6 square root of 3. So in this case, for this question, you have at the bottom, you have 3, and the top, you have 6 square root of 3. But this example here, what you can do is, this 3 will divide into this 3 twice. So giving you the value answer 2 square root of 3. That's just a simple division of numbers. 6 divided by 3 is 2. So you know that. Let's try this with this question here. So here, we want to rationalize the denominator. So we're going to multiply everything by the bottom identical. Remember, the denominator is the bottom number. So we're going to multiply everything by square root of 6. And then we're going to multiply this one by square root of 6. So what does that give us? That gives us square root of 8 times square root of 6, square root of 6 times square root of 6. We know square root of 6 times square root of 6 is going to be square root of 36. Yep. And then square root of 8 times 6 going to be square root of 5 times 6 is going to be 48. And then we know square root of 36 is just going to cancel down to 6. And square root of 48 could just stay as that if you wanted to. Or if you want to look even smarter, you could simplify the top surd. Remember, square root of 48, you could simplify down to square root of 4. And that will go down in 4 times square root of 2, square root of 12. So square root of 4, that becomes 2 square root of 12. You could actually even simplify this one down even further if you want to do. You could go 2 times square root of 4 times square root of 3. So remember, this square root of 12 is square root of 4 times square root of 3 simplified. So that's, you know, that is going to simplify. So you got 2 times 2 times square root of 3. So that means the answer becomes 4 square root of 3 at the top. So here it becomes 4 square root of 3 over 6. And again, if you wanted to highlight, this also will cancel this down because 2 will go into this twice, 2 will go into this 3 times. So then the answer becomes 2 square root of 3 over 3. It's a bit more trickier, but again, go through the process and you'll see. If you go through the process step by step and using all the rules you've learned so far, you should be able to come to the same answer. So this is now looking at a slightly more difficult question. So rationalizing the denominator, where the question has a 2 plus square root of 3 at the bottom. In the previous section, you only had square root of 3, which you could multiply by square root of 3 to get to just the value, the rational number 3. But in this case, it's not as straightforward. So what you do with these type of question, when you have these 2 plus square root of 3, you do the same as what you did before. You multiply the same number at the top and the bottom, but rather than using the positive sign, you just change the sign to go use the negative sign. 2 minus square root of 3. And the reason you use this is because you form these 2 plus square root of 3, 2 minus square root of 3. This is dots, difference of 2 squares. So if you remember your difference of 2 squares, you had a squared, a plus b, a minus b is equal to a squared minus b squared. So this is dots, difference of two squares. Yeah. So we basically try to use the same rule here. So if you, again, all you have to remember to do is rather than using 2 plus square root of 3, you multiply by 2 minus square root of 3. So you change the sign. So if you did that, again, from the top, 2 minus square root of 3, you could just put the 2 minus square root of 3 and leave the 2 outside to put it into a bracket. And if you did that from the bottom, what happens at the bottom is if you multiply 2 plus square root of 3, 2 minus square root of 3, you multiply each of them together. So 2 times 2 will give you 4, and 2 minus square root of 3 will give you minus 2 square root of 3. And now if you go to the bottom, 2 square root of 3 will give you plus 2 square root of 3. And then if you multiply square root of 3 with square root of 3, positive and negative, so that will give you a minus 3. Remember, square root of 3 times minus square root of 3 will give you minus square root of 9, and minus square root of 9 will just cancel down to minus 3, and this is that minus 3. So minus 3 and 4 you could just add together now. So 4 minus 3 is just 1, and then minus 2 square root of 3 plus 2 square root of 3, those ones will just add and take away to give you 0. So the answer at the bottom is just 1 here. It all cancels down because 4 minus 3 is 1, and then minus 2 plus 2 is 0. So minus 2a plus 2a, if you remember, plus 2a will just become 0. So this is the same. Minus 2 square root of 3 plus 2 square root of 3 is 0. So now we just worked out the bottom, which is 1, and the top is going to be 2 minus square root of 3. And then this just simplifies to 2 minus square root of 3. And if you can, leave it like this if you want, or you could even go further and expand the bracket, multiplying this by this and this by this. So that will give you 4 minus 2 square root of 3. And that will be your answer. You can, with these questions, I know they look difficult, but if you go through the simple steps, it does look a lot straightforward. So I think it's all about practice. If you practice, 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 if you need to, what you can do is pause the video, then go back and look at it again, and hopefully you'll understand and when you go through it, and it will become easy for you to then answer these type of questions. These are normally grade 7 mark questions. Grade 7 questions. So thank you for watching this video. If you liked it, please remember to subscribe. I'll try to add more and more video once every week. Hopefully, if I get more people, commenting or suggesting ideas, I will try to do those topics next. So thank you for watching and enjoy revising.